Hi class, welcome to your first video lecture talking about the fundamentals. So much of a preview of old algebraic methods as we move into the pre-calculus course. So this first lecture is going to be about different types of equations, so how you solve equations. So we're going to have three objectives as we work through this lecture here. We'll talk about how you solve linear equations, solve quadratic equations, and then finally we'll talk about other types of equations. Okay, so first off, we'll start with solving a very simple linear equation. So if you want to solve this equation, 7x minus 4 is equal to 3x plus 8, well, we know that we need to solve this by changing it into an equivalent equation with all terms that have an x variable on one side and all constant terms on the other. So when I rewrite our equation as 7x minus 4 is equal to 3x plus 8, the first thing I want to do is I want to get all the constants to one side. So I'm going to undo this minus 4 by adding 4 to each side. So this minus 4 and 4 will cancel, and then the like term over here, 8 plus 4 gets me 12, like this. So the next thing I'm going to do is I'm going to take this 3x and I'm going to subtract it from each side, okay, to get everything with an x on the left-hand side. So when I do that, I just get 7x minus 3x gets me 4x is equal to 12. Now at this point, you can either divide both sides by 4, or here what I'm showing you is I multiply by 1/4. The 1/4 and 4 cancel, and you're just left with x is equal to 3. Now it's generally good practice to check your solutions, right? So you can plug the solution you got, x is equal to 3, on both the left-hand side and the right-hand side of the equation. And when you do, it'll check out, or you'll know that you got the right answer if both the left-hand side and right-hand side are equal, which they are here. Okay, so we're good, it checks out. Let's try this one. So let's find all real solutions of the equation x squared plus 5x is equal to 24. So now whenever you have a squared term here, the quadratic, what you're going to want to do with something like this is you're going to want to take the 24, okay, and you're going to set the right-hand side equal to 0. Okay, so you're going to subtract the 24 over, and then you're just going to get x squared plus 5x minus 24 is equal to 0. At this point here, the first tool in your toolbox to solving these quadratic equations is going to be to factor. So, you look for two numbers that multiply to minus 24, sum to 5. Well, that would be positive 8 and 3. So this will factor into x minus 3 times x plus 8. So that's good. Next, you're going to use the zero product property. So either x minus 3 is equal to 0 or x plus 8 is equal to 0. Well, solving this, one solution is just going to be x is equal to 3, and the other solution, subtracting the 8 over, will be x is equal to negative 8. All right, so the solutions here, as we see, are x is equal to 3 and x is equal to negative 8. So you're going to want to check your answers. So I'm going to take my 3, I'm going to plug it into the original equation. Yes, it does equal the same thing as the right-hand side, 24, and the same deal with negative 8. Okay, so they both check out. They both work out perfectly. All right, let's try these two, okay? So let's find all real solutions for the following equations. So the first one is going to be x squared is equal to 5, and then the second one is going to be x minus 4 squared is equal to 5. So the subtle difference there. Here I just have x squared, here I have x minus 4 squared. All right, so for the first one here, from the principle in the preceding box here, or from a previous course, we know that to undo a square, we take the square root, but when you take the square root to solve, you get two solutions. You get plus and minus the square root of 5 here. So that's one answer. It could be very important that when you take the square root to solve, you get both a positive and a negative solution. Okay, same thing over here. Okay, so just to go back to this, there's two solutions. One is plus the square root of 5, and one is minus the square root of 5. Positive square root of 5 and negative square root of 5. Same deal here. We're going to take the square root of both sides, okay, to undo this square to get the x minus 4 by itself. Now when I do, again, you get two solutions. I took a square root to solve, so it's plus or minus the square root of 5. So now I'm going to do is just add the 4 over here. So what we're seeing here then is I have two solutions. One is 4 plus the square root of 5, and another one is 4 minus the square root of 5. So when you take the square root to solve an equation, two solutions. One's positive, one negative. All right, we can use the technique of completing the square, which we've learned in previous math courses, to derive a formula for the roots of the general quadratic equation ax squared plus bx plus c is equal to 0. So whenever you have an equation, a quadratic equation of this form, that ax squared plus bx plus c is equal to 0, So these values a, b, and c are the coefficients. All right, just important to note that a cannot equal 0 here. Then our solutions are x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's try this one. Let's find all real solutions for this equation. So I have 3x squared minus 5x minus 1 is equal to 0. So what we're going to see here, all right, in this quadratic equation here, all right, my value of a is the coefficient in front of the squared term is 3. My value of b is this negative 5. So whenever there's a negative with it, when you go to use the quadratic equation, it goes along with the value. And my constant term, c, is equal to negative 1. So what I'm going to do here is I'm going to take this, my a, my b, and my c, I'm going to plug it into the equation right here. So when I do, I get negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 1 all over 2 times a, which is 2 times 3. So all you have to do at this point is just clean this up, okay? Underneath the radical there, if you put that in correctly, you get 37. So we have two solutions here. We have 5 plus or minus the square root of 37 divided by 6. So we have two solutions, okay? So if they ask you to give me a solution to x number of decimal places, you can use a calculator. So one is 5 plus the square root of 37 over 6, which is roughly 1.8471. And then don't forget you have the negative. So 5 minus the square root of 37 over 6 gives me roughly negative 0.1805. Okay, that should be it. Went through that pretty quick because that's a quick review. So I want to talk just real quick about how you solve other types of equations here. Okay, ones that might be a little bit more tricky. All right, so far we have learned how to solve linear and quadratic equations. Now we study other types of equations, okay, including things with higher powers, fractional expressions, and radicals. All right, so let's start with this one, some rational equation here. 3 over x minus 2 over x minus 3 is equal to negative 12 divided by x squared minus 9. All right, so this is really complicated because it involves it involves fractions here and the variables in the denominator. All right, so what we want to do here is we want to eliminate the denominators by multiplying each side by the lowest common denominator. So the lowest common denominator here, the LCD here, would be x times x squared minus 9, which would be the same thing as x times x minus 3 times x plus 3. So the first thing you're going to do with these type of equations is find the LCD. Okay, so I'm going to multiply both sides of the equation by this. So watch what happens when I do. I'm going to multiply this side by the LCD and this side by the LCD. All right, so this gets distributed over here. Well, you have 3. This x will cancel with this x, so you're left with x squared minus 9. Minus this x minus 3 will cancel an x minus 3 in here, so you're just left with minus 2 times x plus 3 is equal to x squared minus 9. That x squared minus 9 is gone, is equal to minus 12x. So once you have this, that's a piece of cake. Now it's just a straight quadratic equation. You just need to simplify it. Okay, so the first thing I did here was I distributed the 3, and then I distributed the minus 2x, and I get the following. So I'm just going to clean this up now. 3x squared minus 2x squared gets me x squared. I have my minus 6x and then minus 27 is equal to 12x, minus 12x. So next what I'll do is I will add 12x to each side. So I'm left with x squared minus 6x minus 27 is equal to 0. So now you're going to solve this by factoring. Okay, so you're going to say, okay, well, what two numbers multiply to negative 27 and sum to 6? Well, that's positive 9 and negative 3. So then just using our zero product property that we know, either x minus 3 is equal to 0 or x plus 9 is equal to 0. So solving this, one solution is x is equal to 3 and another solution is x is equal to negative 9. Incredibly important at this point here. You need to check both solutions. Okay, so you must check our answer because multiplying by an expression that contains the variable can introduce extraneous solutions. Okay, so when we check our answers, we actually see that the only solution here, this solution x is equal to 3 doesn't check out. Okay, the only solution is x is equal to negative 9. And the reason is because when you go to check your answers on the left-hand side here with x is equal to 3, you get a divide by 0. Okay, because it was x minus 3, but when you plug in 3 for that, you get 3 minus 3 is 0. Undefined. Doesn't work out. Okay? And also the same thing on the right-hand side. Doesn't work out. So when you checked with x is equal to -9, plug it into the original equation. Both the left-hand side and right-hand side of the equation were equivalent. So that's great. All right, let's end by doing this problem. All right, this one involves a radical. It's a little bit crazier. All right, so first thing, how are we going to solve this one? All right, so I have x squared is equal to 1 minus the square root of 2 minus x. All right, so to eliminate the square root, we first isolate it on one side of the equal sign, and then what we do to get rid of a square root is we square it. So I'm going to take this 1 and I'm going to subtract it over. Now I'm going to square both sides, okay? So that becomes this squared. A negative squared is a positive, and then the square root squared cancels, and you're just left with 2 minus x. So now you have to just solve this, okay? And it's pretty straightforward. What you're going to do is you're going to FOIL this out here, okay? So you're going to expand it. So 2x minus 1 squared becomes 4x squared minus 4x plus 1, okay? And then you still have this 2 minus x. And what you're going to do is then you're going to subtract the 2 over, so this will become minus 1. You're going to add the x over, so you get 4x squared minus 3x minus 1 is equal to 0. At this point, you can check to factor this, and it will indeed factor into the following. 4x plus 1 times x minus 1. So we just use our zero product property, excuse me. So we have 4x plus 1 is equal to 0, or x minus 1 is equal to 0. So one solution here is x is equal to negative 1/4. Another solution is x is equal to 1. And these values here are only potential solutions. Again, you must check to see whether they work out, all right, and satisfy the original equation. So when you do that, actually what you see is that only x is equal to minus 1/4 checks out, but x is equal to 1 does not check out. Okay, so you need to plug it back into this original equation, okay? And you'll see it just doesn't work out, okay? Because if you plug 1 in here, you'd get 2 times 1. This is 2. This would be 1 minus the square root of 2 minus 1, so this would be 1 minus 1 is 0. It doesn't work out. So only that one solution checks out. X is equal to minus 1/4. Really important to check the solutions that you're seeing on the rational equations and the ones with radicals. And here you can see how this x is equal to minus 4 checks out, whereas the x is equal to 1 doesn't check out.